Continuing with our example for work sampling, the secretary of the college department has estimated that a printer will be used 40% of the time. A work sampling study was conducted to see the proportion of the time the new printer is used. The study must be within 4% of the actual proportion with a confidence level of 90%. So we want to determine the sample size of the work sample to achieve this. Now, looking at the example, ang given is yung 40%. So, the printer daw will be used 40% of the time. So, that denotes the value of your P or the proportion. And then, the study must be within 4% of the actual proportion. So, that is your error. And our confidence level is 90%. So, for the solution, susulat natin yung given. So, your P is 0.4 and then your confidence level is 90% while our error or yung L is 0.04. So, you want to know the value of your N. So, again, based on sa formula ng value ng N, so which is PQ times yung Z alpha over 2 squared, that's over your L squared. So, at a confidence level of 90%, yung ating Z is 1.65. And N therefore is 0.4. And then times 0.6 times yung 1.65 squared over 0.04 squared. So that will give us a value of that's 408.38 or equivalent to 409 samples. Next, for example 4, a work sampling study was conducted during an 8-hour shift wherein 400 pieces were produced. It was estimated that 80% of the total time the machine is running and the machine was rated at a 105% rating factor and given an allowance of 12%. We want to calculate for the standard time of the process. Now, let's write the given information. So, ang sabi, your T is 8 hours or equivalent to 480 minutes. Then, yung ating units of production was 400 pieces. And that our proportion is given at 80% or 0.8. Our rating is 105% and our allowance factor is given at 12%. So, first is we need to find the value of your observed time or yung OT. So, OT is T over P times yung NI over N. So, binigay na tayo ng value ng N or ng P sub I which is yung 80%. So, ibig sabihin, this is your P sub I. So, substituting in the formula, so our OT therefore is yung 480 divided by your 400 times 0.8. So that will give you a value of 96 minutes. Next is to solve for our normal time. So normal time is OT times R. So that's 0.96 times yung 105 divided by 100. That's 1.003 minute. And our standard time, so 1.008 times 1.12, that should be 1.13. That's 1.13 minutes. Next example, number 5. A manager conducted a work sampling study in the warehouse where there are 18 employees who locate items, pull them, and put them to conveyors to the packaging area. The study ran for 5 days, and out of 50 random observations, it has been recorded that employees are idle 400 times. So the manager wanted to know how many more number of samples must he take to achieve his goal of having a minimum error of 3.5% at a confidence level of 90%. Now, looking at our example, you might wonder, bakit idle siya ng 400 times? Now, take note that you have a total of 18 employees. So, 18 si employees, and each employee ay nag-observe ng 50 random observations. So, therefore, our total number of observations will be yung 18 times 50 observations. So, again, you have 18 employees. And you conducted 50 observations each. So, therefore, yung ating N is 18 times 50, and that will be 900 observations. Yan ang sabi, idle daw siya 400 times. So, idle. So, we want to know the number of samples required given an error of 3.5% at a confidence level of 90%. So, yung ating P sub I is yung 400 over 900. And then, yung Q is 1 minus 400 over 900. So, in our actual computation, again, yung ating N is Z also over 2 PQ over L squared. So, pati ito ay naka-square. So, N is 1.65 squared times 400 over 900. And then for your Q, it's just a complementary. And then our error is 0.035. That's squared. So the value of your n that will be 548.75. Or again, you round up lagi. So 549 observations. To continue, example 5. The manager also conducted a work sampling study on the packaging area and discovered that the 30 employees are idle 40% of the time. So downsizing is the best option for the manager to improve efficiency. What is the optimal number of workers in the area? So we just want to know kung ilan ba dapat ang employees na naandun sa area na yun, given that 40% of the time yung 30 employees na yun ay idle. So to know the number of employees that are idle, so number of idle employees is just your 30 times 0.4, which will give you 12 employees. Okay, so therefore you only have 18 employees that should be deployed in the packaging area. Okay, so for the last example, number 6, a local supermarket wants to determine how many cashier stations should be open to accommodate customers. A sampling study was conducted over a 3-day period wherein 20 observations were made. There are a total of 10 cashier stations. How many stations should be open to minimize the cost? If the manager wants an error of not more than 6% at the 98% confidence level, how many observations must be made? Now, for this example, so binigay dito na you have 20 observations and there were a total of 10 cashier stations. So therefore, your total number of observations is just the product of 20 and 10. Now, we are also given the following data. So for the 20-day period of the observation, the following are the number of cashiers that were observed idle during which the observation was conducted. So example, for the first observation, so 3 cashiers out of 10 stations were idle. Sa second observation, so lahat ng stations ay working. For the third observation naman, 1 out of the 10 were idle. So basically, to know or to determine how many times the stations were idle is just to get the sum of the cashier idleness. So we'll just add 3, 1, 4, 2, 2, 2, and so on. So balik natin yung main problem. So 20 observations and 10 cashier stations. So writing the given information. So you have 20 observations and you have 10 stations. So therefore, the value of your n is 20 times 10, and we'll have 20 or 200 observations. Okay? Then we'll just add the total number of idle cashiers. So 3 plus 1 plus 4 plus 2 plus 2 plus 2 plus 3. So 3, 1, 4, 2, 2, 2, 3 plus 3 plus 1 plus 2 plus 3 plus 2 plus 4 plus 4 plus 3 and plus 1. So we have a total of 49. So again, verify. So you have a total of 40 idle cashiers. So yung ating N sub I ay 40 stations. So back to the question, how many stations should be open to minimize the cost? And then so, dahil idle siya, so yung ating proportion, therefore, of being idle is 40 over 200. So, that's 0.2. So, therefore, the number of idle stations is yung 20% of the 10 stations or 2 stations. So, therefore, there should be 8 open stations. Okay. The next question is to know how many observations must be done given that the error is 6% at a confidence level of 98%. So your error is 0.06 at a confidence level of 98%. So the Z value here 2.33 from our tables. So, given that your P sub I is 0.2, so ang N again, ang formula, squared PQ over L squared. So, that's 2.33 times yung 0.2 na P and its complement na 0.8 or 0.80 and yung error natin is 0.06. Do not forget to square the values of our Z and M. That's 241.28 or approximately 242 observations. So since we have already conducted 200 observations, so we only need 42 more observations to achieve the desired level of error and confidence level. So this actually ends the third module for work sampling.